Okay guys, we're about to jump back into Snap and start a new project. But today's project focuses on Booleans. Now, Boolean may sound like a funny name, but it actually comes from the name of George Boole, a 19th century mathematician who actually had some really good ideas about computers before computers even existed. At its core, a Boolean is a true or false statement, simply determining whether or not something in our program or game is true or false. There's a lot of ways to do this though. There's a lot of different Boolean operators. These operators can include greater than, less than, or equal to. Booleans also include other comparison operators like and, or, and not. So we could say it is equal to and greater than, or equal to or greater than, or simply not equal to, and all those other possible variations. So how's an example of what we could actually use a Boolean for in game design? Well, let's say that we're making a game that has pirates, and ninjas, and pirate ninjas. Now let's say that I'm going to be creating levels at random, and on certain levels I want there to be pirates, and on certain levels I want there to be just ninjas, and on other levels I want there to be just pirate ninjas. If I wanted only pirate ninjas, then I would search for pirate and ninja, because it will find something that is only both of those things combined. Not pirates or ninjas, but pirates and ninjas. Now, if instead we told our level to spawn pirates or ninjas, then it would find anything and everything that is classified as any kind of a pirate or a ninja, meaning really any type of enemy could spawn in this level. Now, if I wanted to spawn just one type of enemy, say just a pirate or just a ninja, I would need to use the not operator. If I program a level to spawn pirates, not ninjas, then I'll have only pirates. If I reverse the order and program it to spawn ninjas, not pirates, well, that's what I'll get, ninjas instead of pirates. Okay, so let's take a look at what our new program, our new game, is going to look like today. Once again, we have a sprite that's asking us a question. Right now, it's asking us how long is side A. The big picture here is it's going to ask us for the lengths of 3 different sides of a triangle. Then, it's going to calculate what the perimeter of that triangle is, and what type of triangle it would be creating. So let's go with an easy one. I'm just going to punch in 10 for side A, 10 for side B, and again 10 for side C. It tells us that the perimeter is 30 and that makes an equilateral triangle. Let's try a slightly different one. This time I'll go with 5 and 5 and 10. The perimeter is 20 this time, and it's an isosceles triangle. Now let's try something that couldn't possibly make a triangle and see what happens. I'll go with 1 for side A, 1 for side B, and 50 for side C. It tells us that these numbers cannot create a triangle. So how do we actually code something like this? Well, let's go take a look. You'll see first off, we have a lot of variables. So let's look at our different variables. We have a variable for the perimeter. That's all of our sides added up together. We also have variables for when we add up side A and B, a variable for the sum of adding A and C, and a variable for the sum of adding sides B and C together. We also have a variable for each side on its own. Side A, B, and C will each be stored as their own variable. And right at the beginning, we initialize all of these to 0. Then we get to the player interaction. It asks us, how long is side A? You just saw an example of that. When you punch in side A, just like the project we've done recently, where the game memorizes our name as a variable, this time we're memorizing the length of side A. So we are setting side A to be equal to the answer that the player just input during this process. Then we repeat the same thing with side B and C. So when you write this little chunk of code right here, you can just duplicate it and then change what variable we're interacting with and change this from saying side A to saying side B and side C. Now, after the player has input what all these variables are going to be, the game is going to do a little bit of math in the background. It's going to set this A plus B result variable to be equal to side A plus side B. The same thing for side A plus C and B plus C. We simply take those variables that were stored and add them together and set these results to be equal to, well, the numbers that the player inputted added together. The next step is to check and see if we can even make a triangle out of these. If A plus B is greater than side C, then these numbers can't create a triangle. The same is true if A and C are greater than side B. We can't make a triangle with these numbers. And the same is true if the sum of b and c is greater than side A. For each of these possibilities, we say if this is true, then the computer will tell us that these numbers cannot create a triangle. And that's the end of it. However, if we make it past all of these possibilities, if we can create a triangle, then we go down and we set the perimeter to be the A and B result plus side C. Now there's more complicated ways that you could do this. You could take side A plus side B plus side C, but if we already have the result for A and B stored here, and side C is the only part that hasn't been added in yet, this is a nice efficient way to do this with what we already have lying around. And then it will simply tell us the perimeter. So here we are setting the perimeter to A plus B plus C, and then we're telling it to the player. After we've determined whether or not we can create a triangle, and then determined the perimeter of that triangle, it's time to determine what kind of triangle it would create. Now the paperwork in your lab will help you out with this, because it reminds us that an equilateral triangle, well, all three sides are equal. So how can we determine if this is an equilateral triangle? Well, we can simply say that if side A is equal to side B, and side A is equal to side C, then it must be an equilateral triangle, because that would mean that all sides are equal to each other. There are other ways that you could write this, and I think there might actually be a more efficient way. This is just the first one I stumbled upon, but if you can find a better way to do it, by all means, go ahead and let me know. Now the next one on our list is isosceles, which takes a little bit more work, but you can mostly copy and paste this. We're using a few nested if-elses. And in an isosceles triangle, we need to find out if two side lengths are equal and one is different. So we kind of need three variations on this. We can check to see if sides A and B are equal, and then we can check to see if sides A and C are not equal. So if that's true, we already know it's an isosceles triangle. If that's not true, we go down to our else, and we check to see if sides A and C are equal. But if sides A and B are not equal. If that's true, okay, isosceles is proven. If that's not true, we go down to our last else possibility, and we say if sides B and C are equal, and sides B and A are not equal, then that's our last chance to find an isosceles triangle. Now nested within our last else, I've got another if for how to make a scalene triangle. Now, if you've made it this far, you already get full credit for the day. You don't need to create a scalene triangle. But if you're passionate about your project and you want to earn some extra credit points, if you can figure out how to use booleans to determine if we've created a scalene triangle on your own, I'll give you a nice pile of extra credit points. Not required, but give it a shot and let me know what you come up with. Okay, so this is just the big picture review of what this code looks like and how it works. If you want to see me put together most of it step by step, one piece at a time, be sure to check out the next video. I just wanted to split these up into two smaller, more bite-sized videos so they'd be a little bit easier to watch and digest. So if you need more help, check out the next video in Schoology.